Okay, so for the following, we have to find VT and IT. So we're given the formula for VS, but let's first turn this into closed format. So to turn this into closed format, we just add we just subtract 90 from here. So it'll be 20 sine 10t minus 60. All right, and let's get the impedance values for both of these. So the impedance value for this will just be 4 ohms. The impedance value for this inductor will be the inductance value, sorry, an imaginary number, which will use J instead of I, and not get confused with this I, times the angular velocity times the inductance value. So the angular velocity is whatever is being timed by t. So it'll be 10 times 0.2. All right, and 10 times 0.2, that's just 2. So it'll be J2, that's your impedance value. So J2 ohms. Now for this, let's start by putting this into phasor domain. So it'll be 20, and then here we put the degree. So we put this part out here, and then we put this symbol that's supposed to be the phasor, and then here we put the degree, this part of the degree in here. Now, what we're gonna do is separate all the. We're gonna separate this into put all the complex numbers and imaginary numbers aside. Okay, to do that, we're gonna use the following formula: cos x plus the imaginary number times sine x. Okay, so first thing we have to times this by 20, so it'll be 20 cos x plus j20 sine x, and then x will be this, so it'll be 20 cos minus 60 plus j20 sine minus 60. So the first part I get 10, and the second part I get, whoa, sorry, my pen dropped. So it'll be minus 17.3205 J. Okay, so that's my VS value, and I'm gonna use that. I'm gonna be working with that. Well, that's such horrible handwriting. Okay, now I know the following is true. I know VS will be equal to our current I times the sum of all the impedance values. So VS was 10 minus 17.3205 J, and this is equal to I, and our impedance values, the sum of all of them, will be 4 plus 2J. Okay, now divide both sides by 4 plus 2J. And this will be your I value. Now we have to get all our complex numbers on the top. So what we can do is do 4 minus 2J. But this is time consuming. So what you can do instead is set up your calculator into imaginary mode or complex mode. So you do 10 minus 17.3205, and then you press shift and then press the complex number I, and then you divide by 4 plus 2 shift I, and this will give you your real numbers, which is 0.26795. Then press shift equal again, and then you get your imaginary number, which is 4.4641 J. This will be my I value. Let's find a phasor for this. To find the phasor, get the magnitude of these two. So it'll be 0.26795 squared plus minus 4.4641 squared, and then square root all of this. So let me see what that gives me. That gives me 4.472. And then the phasor part, it'll just be tan inverse the imaginary part, which is 4.4641, all over the real part. The reason it's the imaginary part first is because if you were to set this up on a Cartesian plane, the imaginary number is on the y-axis and the real part is on the x-axis. So it'll be minus 4.4641 divided by 0.26795, tan inverse of that, and you get theta to be minus 86.56 degrees. Now, to find the formula, it'll be 4.472 cos WT. W was 10, so 10t minus 86.56 degrees. To turn this into sine format, you just add 90. So add 90 to this. So that's the following. And this is in amps. Now we just solved the first part. Let's solve the second part, which is finding our V value. So we see this V value will be equal to its impedance times the current passing through it. So it will be the following. V will be equal to 2J times I. We're going to be using this I. So V equals 2J, 0.26795 minus 4.4641J. Now distributing the 2J. This is 0.5359J. And the second part is 8.928. Yeah, okay. And now let's set this up into phasor form. So let's find the magnitude. So let me quickly solve that. So the magnitude is 8.9441. And then let's get the degree, which will be tan inverse the imaginary part, which was 0.5359 all over 8.928. And let me see what that gives me. That gives me 3.435 degrees. Okay, so it'll look like the following. Yeah, so to turn this into a formula, it'll be the following. Alright, now to turn this into sine format, you just add 90 to this. Alright, so this will be your VT value, and this is in volts.